Okay, we're going to start with the HL Chem review. Okay, energetics. All right, exothermic heat is released from the system to the surroundings. And then endothermic heat is absorbed. We have energy, exothermic. This would be your reactants, this would be your products. This is your pathway. This is energy. Okay, this is exo. So your products ends up at a lower energy level than your reactants. Okay, defining a term called enthalpy. Enthalpy is the energy contained in bonds. That can be converted to heat. Now be careful with this statement because it always requires energy to break bonds. But if you have bonds that are currently in a compound that are high energy, more unstable, when you break them and they rearrange to form new bonds that are lower in energy, it's that difference in the energy between your products and your reactants that is actually the enthalpy change. But it always requires energy to break a bond. Energy is released when bonds are formed. Okay, so getting back to enthalpy. Enthalpy symbol is H, and you can't really measure the enthalpy of a system, the actual enthalpy or heat content. But we can measure delta H, the change in enthalpy. If delta H is negative, it is exothermic. If delta H is positive, it is endothermic. Okay, delta H negative. Okay, these will be things like combustion reactions, and neutralizations. Okay, I don't think there's many general things for the endothermic change. Things like nitrogen reacting with oxygen to form nitrogen dioxide. This is all gases. This is an exothermic change. Barium hydroxide. Actually, that's a hydrate. That's 8 waters. That's a solid reacting with ammonium chloride, and also a solid. Reacts to form barium chloride dihydrate, which is a solid, plus ammonia, which is actually a liquid, and also aqueous, and then 8 waters. Okay, and of course, energy changes, taking something from the solid to a gas would be endothermic, since you end up at a higher energy state. Exothermic state changes would be going from a liquid to a solid. Okay, if we look at delta H, this little symbol means it's a standard enthalpy change, or standard enthalpy. Since the delta is there, it is the change. And it is defined as the enthalpy change when molar quantities of reactants in their elemental or normal states. That should say normal states. I guess it shouldn't be plural. React to form products in their normal state. At pressure equal to 101.3 kilopascals, which is 1 atmosphere, and stated temperature, and that's typically 25 degrees Celsius, or 298 Kelvin. Okay, that change in enthalpy, it does depend on the nature of the reactants and products. It's kind of a silly statement, because basically that says for different reactions you're going to have different changes in enthalpies. Okay, so really, you have different bonds, you have different bond strengths, so to me it kind of makes sense you're going to have a different change in enthalpy. All right, the change in enthalpy also depends on the amount or the concentration of the reactants. Okay, obviously a higher amount, you have a greater delta H. Your states of your reactants and your products matter. Okay, because changing a state is going to involve an energy change. Your temperature of your reactants, I should say of the reaction, and sometimes the pressure at which the reaction is carried out. Okay, that's where we'll end the first one.